Okay, Unit 5, Lesson 6. We're going to look at the process of converting from standard form to vertex form by completing the square. And in this lesson in particular, we're going to look at standard form equations that have a value of a that's not 1. It's like something bigger, 2, 3, 4, and including negative values as well. Okay, so let's start by converting from vertex to standard, something we should be familiar with. It's just expanding. So here I have y equals 2 times x plus 3 squared minus 7. So the way we expand this is by writing the x plus 3 squared, expanding that as x plus 3 times x plus 3, and then minus 7. Then we expand the x plus 3 times x plus 3. So we leave the 2 out for now. Here we have x times x, which is x squared. Then 3x and 3x make 6x, so plus 6x. And then 3 times 3 is 9, so plus 9. And then we have a minus 7 outside. Y equals, next line, distribute the 2. So we have 2x squared plus 12x plus 18. And then minus 7 outside. And collecting these two like terms at the end gives me y equals 2x squared plus 12x plus 11. And here's our standard form. And from the standard form, we can find our y-intercept. Y-intercept is 11. Okay, and here we go. We are going to go the other way around. How do we go from standard form back to vertex form? This process of completing the square. So complete the square. So I'm going to start by looking at the a value. So look at the a value, 2. You're going to factor out the a value from the first two terms. Okay, so y equals 2 times x squared plus 6x. So I just factored out the a value from the first two terms. The plus 11 stays as plus 11 outside this bracket. Okay. All right. Next step. So take the coefficient of the x term, divide by 2, and square it. Okay, so take the 6 divided by 2, which is equal to 3. Take that 3, you're going to square it, you get 9. Okay, you're going to add and subtract the result back into the bracket. So here we're going to write y equals 2 times bracket x squared plus 6x. Here we go, we're going to put the plus 9 and then the minus 9. You have to do the minus, otherwise you're going to be changing the equation, changing the value of the equation. And then outside the bracket I have plus 11. Okay. Then you recognize that these three terms inside the bracket make up a perfect square. Okay, x squared plus 6x plus 9 can be written as, let's write it like this. So y equals 2 times square bracket x squared plus 6x plus 9 is x plus 3 squared. I still have a minus 9. Let's close the square bracket, and you have plus 11. So just remember these square brackets, where they come from, these are just these round brackets that become the square brackets because I'm creating new brackets inside. Okay? Then we are going to distribute the 2. So y equals 2 times x plus 3 squared minus 18. 2 times 9 is 18. Then you have a plus 11. And then finally collecting the two terms at the end gives us 2 times x plus 3 squared minus 18 plus 11 is minus 7, which is exactly what we have up here. So that's how you get your vertex form. Now the alternative way of getting the vertex form is, again, starting by getting the axis of symmetry, which is the x value of your vertex, which is also your h value, by doing negative b over 2a. And so if you look at the standard form tells us that a is equal to 2, b is equal to 12. So negative b over 2a is equal to negative 12 over 2 times 2, which is 4. So 12 over 4 is just 3, negative 3. So there's my h value. So if I want the k value, plug it into your equation. So the equation is y equals 2 times x squared, so negative 3 squared, plus 12x, so 12 times negative 3, plus 11. If I evaluate that, I get a y value of negative 7. So that's your k value. Okay? So k equals negative 7. So the vertex is negative 3 and negative 7, which means the equation is y equals, use the same a value as in the standard form, so the 2. So y equals 2 times x minus h, or x minus h squared plus k, which, so if we know h is negative 3, we're going to say y equals 2 times x minus negative 3, which becomes plus 3. The double negative becomes plus. So x plus 3 squared, and then minus 7 for k, so minus 7 at the end. And this is a much shorter way of doing it, of course. But the reason why I showed you the proper completing the square method is because it is required by your curriculum for me to teach you this. But it is also very useful to understand how this process works. Okay, let's look at another example. So again, let's go from vertex to standard. So y equals negative 3 times x minus 2 squared minus 1. So I'm going to expand. So y equals negative 3. Expand the bracket, so x minus 2 times x minus 2, and then minus 1. So when you expand this, do the brackets first, okay? So leave the 3 outside, so minus 3. Then we're going to have, okay, x minus 2 times x minus 2 is x squared minus 4x plus 4. If you want to pause the video, do all the intermediate steps to make sure you understand how to go from that to what I have shown you just here, and then minus 1 on the outside. Distribute 3, so we get y equals negative 3x squared plus 12x plus minus 12. And then minus 1 at the end. And collect those terms, minus 3x squared plus 12x. Minus 12 minus 1 is minus 13. So that's our standard form. Y-intercept of negative 13. And I'm going to take this standard form and convert it back to vertex form. Okay, so first step, factor out the a. The a value is negative 3. You're going to factor out the negative 3 just from the first two terms. So y equals negative 3. Create your brackets. So negative 3x squared divided by negative 3 is x squared. 12x divided by negative 3 is negative 4x. Close the bracket. Leave the minus 13 outside. You're not dividing the 13 by 3 because it's not being factored out. It's only being factored from the first two terms. Okay, now notice the difference between 12 and 4. Okay, so 4 is the number I'm going to use. I'm going to take that 4. It's minus 4. I'm going to divide that by 2. So it's negative 2. Take the negative 2 and you're going to square it. You get positive 4. So y equals negative 3 x squared minus 4x. You're going to take that 4. You're going to add it. Here it is, plus 4. You're going to subtract it, minus 4. The reason why you subtract again is because you want to balance everything. If you added +4, then you turn the equation to something different in value. Right? And then outside the bracket, you're going to have -13. Then recognize that x, you just created x squared plus -4x plus 4, these three terms here, you've just created a perfect square trinomial, which can be factored using the shortcut. So -3, get some square brackets, x minus 2 squared, and then you have your -4 outside, close the square bracket, and then -13 outside the square bracket. Okay, next step, we are going to distribute the -3 inside my square brackets. So that gives me -3 times x minus 2 squared. -3 times -4 is +12. And then I have -13. Now it's important to note that when you're distributing the -3 inside the square bracket, you're not going to put it inside the round bracket. It doesn't work like that. Remember, the round bracket has a square here, so you can't just distribute like that, and we don't need to distribute like that. So you treat the bracket squared as one term, which is multiplied by -3. And then you have your -4 times -3, which is +12, and your -13 outside. Okay, so then y equals -3 times x minus 2 squared. 12 minus 13 is -1. And there you have it. There's our vertex form. It's in the form of y equals a times x minus h squared plus k. So that's what you see there, and that's what we originally had on the left side. Okay, let's do a word problem. So example 3, the path of a ball is modeled by the equation y equals -x squared plus 2x plus 3, where x is the horizontal distance in meters from a fence and y is the height in meters above the ground. What is the maximum height of the ball, and at what horizontal distance does this occur? And sketch a graph to represent the path of the ball. So maximum height means I need to find the vertex. It would be useful to have vertex form. Okay, so I can convert this to vertex form. So I'll show it to you two ways. One is completing the square method. So y equals -x squared plus 2x plus 3. So I'm going to start by, remember there's an invisible 1 here, so it's a -1. So you start by factoring out a -1 from the first two terms. So -1 comes out, create some brackets, x squared minus 2x, close the brackets, keep the plus 3 outside. Okay. Take that middle term, -2, divided by 2, you get -1. -1 squared is equal to +1. So all you're going to do is say y equals -1 bracket x squared minus 2x, add a 1, subtract the 1, close the bracket, put a plus 3. These three terms make a perfect square trinomial. So I have y equals -1. Perfect square factoring gives me x minus 1 squared. Let's put some square brackets here. Minus 1 and the square brackets and plus 3. So again, these round brackets now become square brackets because I'm introducing a new pair of round brackets here. Okay, now I have a -1 in front, distribute it to the terms inside. So that gives me y equals negative x minus 1 squared. -1 times -1 is +1. I have a plus 3. And if I fix that, I get plus 4. So negative x minus 1 squared plus 4. Here's my vertex form, from which I can get my h and my k. So h is equal to +1, k is equal to +4. So my vertex is 1 and 4. So that means the maximum, y is my maximum height, so the maximum value is 4. So therefore, the ball reaches a max, oops, what happened here? Let's, okay. Ball reaches a max height of 4 meters above the ground at 1 meter from the fence. Horizontal distance at 1 meter from the fence. Okay. Now the other method is to use just to find the vertex. So if you just look for the vertex, so remember axis symmetry, x equals negative b over 2a. So what's my b and a and b values? My a value is -1, my b value is 2 from the standard form. So I'm going to say negative of 2 over 2 times -1, which is equal to +1. Okay, -2 over 2, -2 over -2. And that means I put the 1 back into the equation, y equals -1 times 1 squared plus 2 times x, which is 1, plus 3, gives me a y value of 4. And then you can say, okay, vertex is 1 and 4. Right? And 4 is your height, and the x value is your distance from the fence. And there you go. So part B says sketch a graph to represent the path. So here's part B. Here's my x and y axis. And here's my y-intercept, 3, max height. Where did I get the 3 from? From the standard form, the c value. Draw your parabola, it's going to go up to maximum, then comes back down to the ground. And the maximum here is at 1 and 4. X-axis is distance. The y-axis is height. And there's your parabola. And that ends this video.